This video is about work and energy. Energy is the capacity. Energy is anything that has the capacity to do work. Now, work in physics is different. Well, let me just also, it's a scalar. We'll talk more about that later. Work is different than the typical definition of work that you use in everyday life. Work is when it is the product, which means multiplication, product of force and the displacement in which the force acts, in which the force acts. Let me slip it in here. In which the force acts. So you have two boxes. They're both applying a force. In this example, we're told that both forces apply make the box move 2 meters. This force, well, they're both 50 newtons, we're told. Nope, that's not right. They're both 10 newtons, and they both cause this box to move 2 meters. So they're both doing work. And you find the work because it's the product, the multiplication of the force that's applied, and the displacement at which the force acts. But if you look at the equation for work, you see it's F cosine theta d, where theta is the angle between the force and the displacement, direction of displacement. So you can see that this object does more work. Why? Because the only part of this force that's doing work is this part over here. Because this component does no work. It does not move the object. If it doesn't act in the direction, Fy does not act in the direction of the displacement, or, well, let me put it better. It doesn't work with the displacement or against the displacement. This does no work. This component does no work. Any force that's perpendicular to the movement does no work. Now, Fx does all the work. That's why this one does more work, because the entire force acts in the direction of the displacement, either with the displacement or against the displacement. So remember, theta in this equation is the angle between the force and the displacement. In this case, the theta is 0 degrees. Whoops, I just wrote that wrong. Theta is 0 because when the force acts in the direction of the displacement at 0, when the force, well, we'll get to that, negative work. So they both do positive work. What's positive work? Work is positive when the force acts in the same direction as the displacement. So this first guy, call him A. A does positive work, and B does positive work. They both move the box 2 meters, but person B does more work because his or her entire force is acting in the direction of the displacement. Now we look at this, and you could say the only thing that's acting in the direction of the displacement, which is towards the right, is Fx. Fy does no work. It's acting perpendicular to the movement. So work is positive when the force acts in the same direction as displacement. Work is negative when the angle between force and displacement is 180. Like, this is not complicated. If I threw a baseball at you, your mitt would do negative work because the baseball is going towards you, but the force of the mitt is in the opposite direction. When the force and displacement are opposite, 180 degrees, we say that negative work is being done. When the force is positive, when the force acts in the same direction as the displacement, like when you throw the baseball, you're doing positive work. Your force is in the same direction as the motion. Now, here's a third little scenario. Let's see if you can remember this. When the angle between the force and the displacement is 90 degrees, work equals 0. Let's go back to that again. That's why we said that the Fy, the vertical component, does no work because the object moves to the right and Fy is perpendicular to that movement. When the angle between the force, the applied force, and the displacement is 0, we say that that force does no work. So actually, no, I don't want to go there. I just had a thought, but I don't want to go there. Negative work would be catching a baseball. Catching a baseball is negative work. Throwing the baseball is positive work. Positive work. Throwing a baseball, because your force is in the same direction as the displacement. So you throw a baseball to the right, you apply a force over a distance. When you throw a baseball, you don't think about this, but your hand is on the ball over a certain distance. It's a small distance, but it is some distance, and that's the work you do in throwing it. That'd be positive work. Catching the baseball, negative work because the force is in the opposite direction of the displacement of the ball, and positive work is in the same direction. And 90 degrees is no work at all. Here's another. It's an example. If I'm walking with holding some books, my hands are pointing up, and if I move the books to the right, I can't say that my hands do any work at all. Um, in moving the books, if the book goes to the right, my hands are pointing up. It's not the hands that do work. Now, your hands hurt and all that, but the physics definition of work, we would not say that the hands did any work. Work, if you force and displacement are perpendicular, it's no work at all. Now, I told you before why I was going to tell you why work and energy are both scalars. Let's take a look at an example. A 5 Newton force acts over a distance of 3 meters. 5 Newton force that's acting north causes an object to move 3 meters north. So how much work is that? That's north. That's 15 joules. I didn't say that the force was north, so let's assume 5 times 3 is 15. There's no angle. Now, then that same 5 Newton force acts 4 meters east. That's 20. So imagine this is you pushing a dresser. You think the dresser should go across the room, then you change your mind, you take a right-hand turn, and you end up over here. Now, if this were a vector, we would say that, well, really it's equivalent to this over here. I could use the Pythagorean theorem. 15 squared plus 20 squared, take the square root of that, but it is not a vector. And it would be ridiculous to say that whatever this hypotenuse was, really the work was to say that it was equivalent to 15 plus 20. The work is 35 joules. You have to add them up. With scalars, you always just add them up in the regular way. With a vector, if this was a vector, which it's not, I could use the Pythagorean theorem and say it was equivalent to those two vectors using the Pythagorean theorem. But it is a scalar, and you just add them up like you add up any scalar. Uh, if I said it was 90 degrees out and it increased 5 degrees, well, it's always 95. You add vectors like you do simple mathematics.